So my name is Austin.
My name is Julia.
I'm Michael. We all graduated recently from Team U, the chemical engineering department.
So the main purpose of our plant is to recycle flexible polyurethane, which we will answer later. But basically, we try to make a renewable and using advanced technology to recycle material to ensure the environmental aspects as well as the productivity of the plant. Polyurethane in its physical form is foam, which you can find in mattresses, furniture, and in its chemical properties is a polymer composite where it forms by monomers, which is polymer, and then there's isocyanates as part of it.
We had a list of topics to choose from, and this one stood out to us because it was a recycling plant. We were able to, instead of creating something, we wanted to see if we could recycle something. So that one stood out to us, and we specifically chose that.
The main issue for us is that right now there isn't a formal way of recycling polyurethane. So essentially we were looking at different aspects to essentially determine different perspectives that we can take into finding a more cutting edge, more environmentally friendly as well as sustainable method of recycling your end-of-life polyurethane.
For our plants, a lot of the sustainability came from recycled streams or recycling of energy. For example, if we had a raw material go into the plant and it was coming out because it wasn't used anymore, we took that, instead of putting it to waste, we decided to bring it back and recycle it so it's constantly used.
Polyurethane is a material that you might not know what it means by its scientific name, but you use it every day. For example, like the mattress you sleep on, it's made of polyurethane, the sponge, your car seat, even the dishwashing sponge that you have on your countertop, that's all polyurethane. And so it's such a pressing issue because we have so much of it and we don't know what to do with it at the end. And I remember that there's a statistic that we had out there that said if you were to stack all of your mattresses, the end-of-life mattresses, it would be approximately 900 times the size of Mount Everest.
For our project, we wanted to focus on mattresses itself. The topic was broad, it was polyurethane, but we decided because of that statistic, we wanted to take the mattresses and figure out where we could get them from, how they could be broken down, and then do the process for just the mattresses.
And also we're trying to make some profit out of it as well in order to have the funds, in order to using our advanced technology and our ways of ensuring the environmental aspect so that we can sell out the byproducts as well as the main product that we produce after the recycling process.
The main challenge is what we found through our literature review is that polyurethane right now is mostly just discarded and burned.
The current methods that we have right now, a lot of times it is manual removal. So you have people in factories removing piece by piece of your mattress, and then after that they'll feed it into a furnace and burn off the residual materials, which at the moment is horrible. It's polluting the environment as well as making things a lot worse for climate change.
So I mean, in terms of the process, because we're doing this plant design as our main courses throughout our year, so sometimes we are facing a lot of issues with time management where we have to struggle between multiple courses at the same time while having time to figure out new stuff, getting meetings done, and then we're trying to address all the parts of the plant design and make sure all the ideas get through to the end to make the best products as possible.
I feel like starting the project itself, they just gave us a title, right? We had to take that and figure out how to design an entire plant from the title. So starting it off and doing the research and figuring out what's the best way to recycle this polyurethane, that was like the most difficult part. And we had many iterations of our process.
Yes.
So it was a long process.
But the cool part is this course alone is something very close to how you would deal with stuff in industry. So if you were to work firsthand, a lot of times we were on our own. So we went with our gut feelings, our intuition, as well as just based on all the research that we've done. And so at the end, basically following our gut feeling, we were able to come up with something. What separates us from a chemist is that the chemist is able to determine something very lab scale setting, so very small with your beakers and little smaller scale stuff. Whereas we take the information that the chemist determines and we can elaborate and design something that can take that small process and make it into a giant factory. So essentially, this makes it into a chemical engineering process because we have multiple processes going on, a lot of automation, a lot of controls and stuff like that. and we were able to design different methods for the plant.
For us, when we trying to divide our tasks for this plant design, basically at first we all pitch in for the literature review in order to get the first idea started on how we're going to solve these issues. And then each of us focusing on our passion. For example, for me, I'm very interested in terms of the design and the control system as well as the safety of the plant. So I take on that matters.
So for the report, they're broken down into sections, process control, sustainability, everything like that, finances. So I took on the role of sustainability and environmental impact because I'm interested in all of that.
For myself, I was more into the equipment design. So I really enjoyed studying the fluid dynamics. So how the fluids, your materials move out throughout the plant. So I focus more on the pumps, the piping, the fittings.
I would say the main ones were like the 3rd and 4th year courses, equipment design, separation processes, but we used a lot of our early 2nd year courses as well, like thermodynamics, heat transfer, mass transfer. So pretty much every single course that we took played a role in our plant design.
Big or small, yeah.
Yeah, big or small. For me, I'm currently trying to explore different paths I could take in the industries. My current interest lies with the nuclear and pharmaceutical industries as well as project management role. So I'm currently working on the project management certificates as well as some other testing or procedures on the pharmaceuticals as well as the nuclear clearances.
For myself, I'm doing a master's. So me and Michael actually did an accelerated master's. So we did a portion of it during undergrad, and now we're finishing off one more year. So specifically for my project, I'm working on water treatment technology, removing micro and nanoplastics from water. So I'll continue that for this year.
And for myself, like Julia mentioned, I'm also doing a master's. Our project is to use industrial grade absorbents, so fancy sponges essentially, to recover as much rare earth elements as we can from mining trails and hopefully recombine it into usable metals.
I think the most important, characteristic that is necessary for first year students as you just enter a new environment freshly from high school and go into university, there's a lot of changes and there's a lot of things you need to adapt. So I think first thing we need to focusing on is the time management. How did you kind of try to work yourself through the courses, try to distribute your time throughout like the week in order to ensure a good grade on all of the courses?
For me, I would say get involved. I definitely got involved with some student groups and then even doing research. This is where I met all of them and we created our Capstone group. So it's important to make those connections because it will definitely help you in your last year. You want to make sure that you're working with a group that you can bounce off of each other and have a good relationship to create a good project.
And building off what Julia said, of course, yeah, first year is your time to make mistakes, but also it's good to meet new people and become friends with as many people as you can, get to know everyone, enjoy the moment that you have. And above all, I also learned, the professor once told me that the most important thing you can do in first year is learn your math. So it's important to know your stuff, but also enjoy your time while you're here.